Hello students. Today I want to discuss Heisenberg uncertainty principle. In 1927, according to Heisenberg, it is impossible to determine simultaneously exact position and momentum of subatomic particles like electron. What is the meaning of this statement? If you imagine a nucleus and here a circular path is there and electron is revolving in this. Now if what is the position of electron and what is the momentum or velocity of that electron at that particular place, how can you calculate this? If the electron position must be calculated, you have to use the high frequency of light, or it may be said that lower wavelength light. This means the highest energy light is used to focus on the electron. If you use that type of light like this, you will be able to calculate the position of electron. But according to Heisenberg, he said that if you calculated the exact position of electron, the momentum or the velocity will be cannot be calculated, the value will be infinity. How can we can prove that Heisenberg principle? According to this, delta x delta p is equal to h by 4 pi. This is the equation, or you may write it delta x m delta v is equal to h by 4 pi. Now by using this, here delta p is equal to m delta v. Now you can use any of these formulas as you require. What is the meaning of this delta x? Delta x means uncertainty in position, and delta p is uncertainty in momentum, and m is mass of the particle, and delta v is uncertainty in the velocity. These are the meaning of this. And h means Planck's constant. The value must be known, because in exam they will not give that value. 6.625 into 10 power minus 34 joules, or 6.625 into 10 power minus 27 ergs. Both values are important for you. So now how can you prove that statements are not possible for determining same time? If you take the exemplar value, the position of delta x as 26, and now if you reported that value as 24, the actual value is 26, but you reported the position of electron is 24, the difference will be 2. This difference, the delta x value will be taken as a 2, because we said that delta x is the uncertainty in the position. Here the position value is 2, so delta x is equal to 2. Now if you substitute this value for calculation of delta p, or if you want to calculate the delta v, and they have given some m value, now first you go to this formula. If they asked the delta p by giving a delta x value, you can change the formula. Delta p is equal to h by 4 pi delta x. The delta x value, as you said, that it is 2. So now you substitute this 2 here, then h by 4 pi into 2, then you will get some value. But if you report it, this is the case 1, if you can calculate that delta b. But if you reported the value is delta x value is 26, the actual value is 26, now you reported that value is 26, so there is no difference. There is no difference means delta x will become 0, because you have reported correct value, the 26, the actual value is also 26, so delta x is 0. Now if you substituted delta x value 0 here, so you will get h by 0. Anything by 0 is equal to infinity. So delta P will become as a infinity. So this is the main fact. If you identified the correct value, or if you calculate the correct value, that is uncertainty in position, the uncertainty in momentum will become as a infinity value. Here you can see that h by 4 pi into 0, that is equal to h by 0, that is equal to infinity. The same part can be calculated by using, if you want to calculate the delta V and substituting the delta x here, you will able to calculate in same manner. And now if you want to calculate the delta x and delta p value is given, so if delta p becomes 0, now you see we will change the formula like this. So here the value, now you see the delta p will be 0 if you correctly founded the value, and delta x, here delta p is 0 and del h by 0, that will be infinity. That means delta x becoming infinity value if you give that delta p value exactly. So like this you can see, if you found one value exactly, the another value is becoming the infinity. So this is the main principle of Heisenberg saying that. And from this you can say this is completely not agreeable that Bohr said it has electron will revolve in that circular paths. So that is not possible by using Heisenberg, you can say that. And also the Heisenberg principle is applicable only for microscopic particles like electron, proton and neutron only. You cannot calculate the Heisenberg principle for the heavy particles like cricket ball and also like aeroplane or etc. That macro particles cannot be calculated by using this principle, because where is that m is present. If you see, if you want to calculate the delta v value, how can you calculate this? If you want to calculate the delta v, h by 4 pi, both these values can be written here, delta x and m. But if you use this m value, higher value, what happens? Here already Planck's constant is 6.625 into 10 power minus 34, and now you are using here heavy mass particle like cricket ball or aeroplane, then the value will become more and more negative value. So more negative value is almost negligible value, because we cannot take that lighter value. Like this, the Heisenberg principle is only applicable for the lighter particles like electron, proton, neutron. You cannot apply this principle for heavy particles, because the m is present here. If m value is very high, already h is minus 34, 6.625 into 10 power minus 34, that negative value will become more and more negative value. Like this it will give the insignificant values. So this is the main principle. And please subscribe my channel Star King of Chemicals. You will reach my latest videos time to time. And thank you for watching.